Hi everyone, in this video I'm going to show you how to use magrittr pipes to simplify your coding. Magrittr pipes come from the package magrittr, and there are many other pipes that are available there. If you want to read more about the details of magrittr pipe, you can check out chapter 18 in R for Data Science book. So magrittr is now folded into Tidyverse packages. So whenever you install Tidyverse, magrittr is also installed at the same time. So you do not have to explicitly install it. Here in the background, you will see the chapter 18, which describes the pipes. And this chapter goes quite in detail. You may not need all the different types of pipes at this point. You basically need the main type of pipe that basically is over here. It looks like greater than, sorry, a percentage greater than percentage sign, which is shown over here, right? So this is the only pipe that we need at this point, but as we code more and more, you might find some other types of pipes equally interesting. So let's understand the functionality of pipes using our code. So I have created a new R Markdown document here. Because magrittr pipe is a function which is inside a package, we need to explicitly call that package. Now, as I said, that if you call simply library Tidyverse, there are certain packages that will be loaded. Now magrittr package, although it is part of Tidyverse, it is not loaded automatically at this point. So when we run library Tidyverse, it is instead going to load dplyr, which makes use of this pipe. So either you can explicitly say library magrittr, then you will get all the pipes, but we are not going to use all of them at this point. Alternatively, you can simply just say library Tidyverse, and the minimal pipe that we are going to use will be loaded automatically. So I'm going to go with library Tidyverse. So let's execute that. Okay, so we get all these messages saying there were some conflicts, there were some, it has to attach some packages and so on. It doesn't matter. All right, so let's begin with a very basic function where I'm going to add two numbers, 5 and 7. So sum 5 plus 7, right? And that is, of course, 12. Now we are going to use magrittr pipe that looks like this. Now it looks odd, right? It is percentage greater than percentage. How do we get that quickly? Like, do I have to type percentage greater than percentage every time I have to use a pipe? The answer is no. There is a keyboard shortcut in RStudio. It is Command Shift letter M for Mary in a Mac, and in a Windows system you have to use Control Shift letter M. So the only difference between Mac and Windows is Command and Control key. That's it. So if you press these three keys together, you will get, you should get the pipe symbol. All right. So how does pipe work? So pipe helps us isolate the first argument to your function and the remaining function. So in our function in line 14, which is sum of 5 and 7, the first argument to the function is 5, and the remaining part of the function is sum 7. So if I write it like this, if I say 5 and followed by a pipe, and I say sum 7, that is exactly the same as line 14. As you can see that I get the same answer. So what's happening here is that I'm literally splitting the function and its arguments into two components. So first argument goes on left and then we put pipe, and then we put the remaining function. So when you execute this line, sum function will first look for its first argument on its left of the pipe, and whatever is that value, it is going to put that value inside this sum. Now, one thing you have to be sure of is that it is your responsibility to make sure that the value on the left side of the pipe matches the argument required on the right hand side of the pipe. What I mean by that is that consider this function sum. So sum requires numeric values only. It cannot add character values. It's not possible, right? So you cannot add letter A to 7 and expect something out of it. So we should get an error there, right? So if I write A followed by the pipe and I say sum 7 and try to execute this, of course I'm going to get an error like this. Or I could do like the character, okay, and then try to execute. Now I'm still going to get an error, and this error says that I have given invalid character type to the argument, right? So letter A is an incorrect type of argument here. So as you can see, that pipe does not understand that A cannot be added to 7. It doesn't understand it. So the pipe operator is literally picking whatever is on its left and plugging it as the first argument in the function to the right. Pipe does not know whether the value that you are inputting from its left side is appropriate for the function on the right. That is our responsibility, okay? So that will come in play in dplyr, and all the dplyr functions are designed to handle this kind of an issue. So I'll explain that to you in the class. So let's understand the benefit of using this pipe. How does that make our code more readable? But because clearly this line 18 over here, right, has made this code more difficult to read compared to line 14. So my assertion previously that pipe helps with the readability of the code may not be correct, which is right, by the way. In this case, it is making it terrible. But now I'm going to show you how you can make this make the pipe much more interesting. So what I'm going to do is that I'm going to create a very simple data frame first, and then we are going to make some operations on this data set. Okay, so we'll say this is a data frame called as d1, and we'll say this is data.frame, and here I'm going to create variables. I'll say first variable is a, which takes first 10 values 1 to 10. Then there is another variable called as b, and that is going to hold English alphabet from 1 to 10. And so there in R there is a vector called as letters that has all the lowercase letters from A to Z. Then I'm going to also create another variable called as C, and that is literally going to have a normal distribution, 10 values, that's it. So with this we have now a new data frame. All right, so I created this data frame. By the way, because I used a random number over here, when you do this exercise, you are likely to get different values there. I mean, you are guaranteed to get different values, unlikely to get the same values as me. All right, so now what are we going to do with this? So I'm going to perform some very simple operations on this. All right, so what I want is that I want, first of all, from this data frame, I want to pick the first column and the third column. That is only the numeric columns, right? So A and C are the two columns I want to extract. and then I want to find out the summary of this. So we are using some of these functions from dplyr package, but before we do that, we also want to create a fourth variable d, which will be the sum of a and c, right? So I'm going to perform multiple operations here. So let's do that. Let's go in this sequence. First we will create a new variable d, then we are going to retain only a, c and d. We will remove b from this data frame, and then we will take the average of a, c and d. Okay, so let's start. And so first of all, I'm going to create a new data frame. I'm not going to override this, and the way we create this in using dplyr is use a function mutate. So we'll say mutate, I'll say d1, and so d1 is the input data frame. So we're saying use d1 and create a new variable here called as d, and this d variable will be sum of a and c. All right, so now this d2 is a new data frame that will have 4 variables instead of 3. So let's run this, and if you are curious to know, we can click on d2 and take a look at that, and this is what I will get. And so as clearly you can see that variable d here is the sum of a and c. Okay, so once this is done, we move on to the next step. Now we want to create a new data frame again, because I personally don't like to overwrite the existing data frame. So I'm going to now select from d2, I'm going to deselect b, so I can write it like this, minus b. So that means it is going to drop the variable b, and it is going to retain a, c and d with this. But if you find this confusing, you can also explicitly mention what you want to keep. So you can say a, c and d are kept explicitly, right? Both the functions will give you the same answer. And once we have this, then finally I'm going to have a data frame called as d4, and that is going to hold the summary of the variables in d3, right? So let's try this now. So I'm going to summarize, and this is, I think, mean. That is the function I have to use. So if I now okay, so there is a, all right, I'm sorry, I have to, so for summarize I need to also give the variables that we are going to use. So I'm going to use a scoping function here called as across. So let me tidy this up so it will be easier for you to understand what I'm doing. I'll say across and say everything. So all the variables in d3 now are used here, and I'm going to say find out the mean for me, and that's it. And so with this, now I have, if you want to take a look at, by the way, this summarized data set, it will look like this. So this d4 is nothing but it has just the means of column A, that is 1 to 10 numbers, and mean of column C, which was a normal distribution. And then it is going to have, remember that we had this sum of A and C, which will be the mean of D in this case. So what's happening here is that it's actually, this is pretty readable, right? If you think about it, you understand what's going on here, right? So each step is pretty much readable. The problem here is that for every step here, every operation, we are creating intermediate data frames, and that's just going to consume memory. So imagine a much larger data frame here. This is going to keep a copy of every intermediate data frame in the global environment, consuming your RAM. That's terrible, right? That's a bad memory management. So one other alternative is to somehow make your job easy by not creating these intermediate data frames. So how is that possible? Well, I can do this. I can say I'm going to create a new data frame called as D41. This is the final data frame, right? So equivalent to D4. However, it is going to follow these steps. All right. It is going to summarize something. Sorry. It's going to summarize, right? And summarize a specific data frame. So this is going to look messy, by the way. I don't recommend this at all, but let's see where we go with this. So summarize requires a data frame to come in, and then this part, the across part, remains the same. So I'm just going to copy it from the earlier step and just going to paste it here. Now we need a data frame. Now the data frame here at this point is coming from D3, which was, remember, it was this select something something, but now this D2 is something that we don't have at this point. We created D2 by mutating D1. So now I write this, and by writing it like this now, so essentially what I've done is that I have taken in line 34, I've taken D3 and I replaced that D3 by whatever was there in line 33, but then we had D2 over there and we don't actually have D2, so then we replace D2 by mutate. And so now you can see that using only D1 in line 38, only D1, I directly reach D41. I do not create any intermediate data frame. So for instance, if I in this case I just I will delete the if I delete D2, D3 and D4, or sorry, D2 and D3, sorry, so I'll just delete that D2 comma D3 and just remove them. So what I did here is, in the console you can see I've used a function called as rm remove. So I'm removing D2 and D3, and now if I go over here in line 38 and execute that line, you'll realize that I get a data frame D41. Actually, let's print both of them so then you will be clear. So print D4 and then print D41, and when you do that, you'll see that they are identical, right? So these data frames D4 and D41, they're identical, and the reason they're identical is because we perform the same operations to reach that final data frame. All right, so this is more efficient because we are not creating any intermediate data frames, right? So D2, D3 were not created, despite that we could get to our final data frame D41. Awesome. So what's the problem? Well, the problem is that this is so confusing, and if I make any mistakes over here, it is very, very difficult to find out where that mistake was. And if I want to do more and more operations, this becomes more and more complicated. So this is known as nesting. I'm nesting functions within other functions, and that nesting causes difficulty in troubleshooting. It creates a terrible code, the code that is terrible in its readability. So that's not something that I recommend. So the solution to this problem, then, an intermediate problem, is to make your code a little bit more complex. It is not going to be as nice as, having these functions separate like over here, but it is going to avoid this problem of creating intermediate data frames. So that is where pipes come in picture. So we are going to now create a third data frame called as D43, which we are going to use, or D42 maybe, yeah, maybe 42, that we are going to use, we are going to create by using only pipes. So how does it work? So first of all, let's go back to our first function here, right? The mutate in line 32, mutate. So in this function, let's start by splitting this function using pipe. So we know that I can take out D1, right? And then write a pipe and then write the rest of the mutate. So let me copy this function over here we'll say, all right, this is the first one, right? So I can, it's not required, but if you want, you can do it. You can split this into two parts. So D1 pipe and then mutate, and make sure that this D1 is removed. So now what it means is that we are saying mutate will require a data frame as its first argument always, okay? And that is basically what we have on the left of the pipe. So D1 is going to get plugged into the first argument of mutate. So it has the correct data frame. Fantastic. Now what? Once I have this, that means I'm going to now have a data frame that was this data frame, right? In line 32, a D2. So what happens to D2 now? So D2 goes into a select. All right. So I'm going to now use a pipe over here. By the way, if you want, you can, make this separate on every line, so we are sure about the flow. And now I'm going to write this select, right? But now in this case, I do not have to write this D2, because on the left of the pipe here, the pipe on line 50, we have a data frame that will resemble D2, right? D2 data frame that we created previously was mutate whatever. This is the data frame that is created in line 49 and line 50. So there is already created, and we are just passing that to the next step, which is in select. Now similarly, now I can use a pipe, and then I can just summarize that data frame. And so when I write like this, of course, I have to again make sure that I don't write that data frame D3, I delete it, right? Because there is no D3 data frame. I'm actually using whatever was created before it as an input to summarize. And whatever I had used before was, I mutated D1, then I selected only 3 variables from D1. Those steps I performed previously, and all of them combined can be now passed on to summarize in one shot. And so this code now is what we have. If I run this, I will get this D42, and if I print this D42, it is going to be identical to what we had before, right? Is identical. So basically we are saying D4, D41 and D42 are all identical. They are the same. But in this case, we have used pipe. So what pipe is doing is that it is taking this D1 I'm in this chunk with line 49. So on line 49 we have this D1 that is passed on to mutate first, and we create a new variable called as D, which is a sum of A and C. Then this data frame, so mutate, by the way, results in a new data frame. So this resulting data frame is passed on to another function called as select. Now select needs a data frame to work with. The pipe tells select that whatever is on your left side, use that as the first argument. Turns out that was the mutated data frame. So select uses the mutated data frame and then decides to keep only A, C, and D. And then a resulting value from this select function is also a data frame. So now this data frame is passed on by the pipe to the next function, which is summarize. So summarize needs the first argument as a data frame. So you might be thinking this sounds too convenient. The answer is yes, it is designed this way. So dplyr functions are designed with this pipe in mind, that the first argument is a data frame. So whatever is on its left will be automatically, it gets plugged without any error, right? So now we have summarize function, which needs a data frame as the first argument. Turns out that that is a selected and mutated data frame that we have already created, that is passed on to summarize as the first argument. And then from that we decide, okay, we are going to just calculate the mean of all the columns in that data frame. And that output, it will also be a data frame, and that is what is saved in D42. So D42 is a data frame that underwent these 3 operations. And these operations are handled by the pipe. So now this code is much more readable, because if first of all, it helps with troubleshooting, right? So if tomorrow if you get an error somewhere and you say, okay, all right, I'm not getting the same output as this output over here, so I will be able to determine that by going here step by step. For instance, let's say that I did not save this variable C, right? So now I get this D42, and this D42 now is going to look different because variable C is missing, and so the output is different. I say, okay, I got A and D, the means of A and D, but not C. So what's going on? Where did I screw up? And then you go back to your code and then say, oh, all right, look here, select A and D. There is no C. So now I add C and I'm back to where I was. So it helps with your troubleshooting because you can read it much more cleanly. It would have been super difficult to do that over here, right? Because, oh, well, it's confusing. So that is the first thing. Second is that it also helps you understand the flow, right? Because in this case, when you have a nested function like this, you find it difficult to understand where you started, right? Like you have to go deep inside to understand, okay, we started with mutate, but hey, you know what? The argument to mutate over here across everything looks like a function too, right? It is a function. So some people might get confused with that. But in reality over here, that across everything is not an argument to mutate at all. It was an argument that was given to summarize. So it is very clear over here, if you go here, you see in the flow that mutate doesn't use any of those arguments like select or summarize. It uses an argument that is a formula that is calculating a new value, and then select just needs a list of variables, right? And a summarize it requires a list of variables, and it requires a function that it needs to perform, because summarize can be used to perform multiple operations, right? You can, if you want mean, fine, but if you want median, you can get a median as well, maybe a standard deviation, maybe a variance, some other statistic. Well, you can do anything with summarize. So summarize needs functions, summarize needs variables, and it's very difficult to see that from here, that this across everything, oh, is it for summarize, or are we even starting with this, or are we starting with mutate? It's tough to read, right? Tough to read. It was clean over here, right, when you wrote separately, but remember the downside was that you had to create intermediate data frames. So pipe avoids those issues with the previous two methods and gives you a more readable code. The downside, of course, is that you are adding a new function over here now. This is a new function, right? That means it is going to take some more time to execute. That is one. And second problem with pipe is that, well, it's not native to R. Now there is a native pipe, by the way, in R, but we are not going to use that in the class. We are still going to stick to dplyr or magrittr pipe. So in magrittr pipe, then because it is it reduces readability to some extent, because anybody who reads this now needs to know magrittr pipe. If they don't know what is magrittr pipe, they may not understand what this is, right? So to that extent, your readability has gone down. So that is where I'm going to stop. I hope you got some idea about using pipes. I strongly advise you to read that chapter 18 and also practice. It's practice that will make it very easy for you.